Welcome everybody to the first experiment in lab flow for 1406, which is chemistry glassware techniques and measurement. I will be going over the experiment first, the write-up of the experiment. I will talk about the main points in the video, in the three videos that you have to watch. And towards the end, I will go step by step over the report that you have to complete today to make sure that you understand the concepts and you can complete the report easily. Please message me and stop me. You can unmute yourself and stop me anytime that you have a question. Otherwise, I will understand or I will believe that there are no questions. I will ask you sometimes, but please stop me anytime. And also, we are going to do some practice problems that you are going to need before you do the lab quiz. Those will help you basically understand the main concept of this experiment. This is the first experiment. It's hard because it's virtual. But you, in the first experiment, you will have to be familiar with the chemistry glassware. What is the glassware that you are going to have in a lab? How do you use them? And how do you measure with those pieces of glassware? So here, in the write-up of the experiment, what are you going to learn after you finish this workshop? Well, look at all these objectives. The main objective is to identify common laboratory equipment, to be familiar, because you're not going to be doing the experiment. It's going to be a virtual experiment, but at least to learn what pieces, the most common, not obviously all of them, but the basic laboratory glassware and simple equipment. So be familiar with that. Also, what is important is to select the appropriate equipment. You have in the lab on the shelves different glassware. Depending on the experiment and depending on the precision that you need to measure, you will know after you finish this workshop what kind of glassware you need, depending on the precision. Also, what kind of, if you need to measure length, okay, what do you use? And what kind of, do you need a ruler with a lot of markings, or depending on what is your precision? So you will have an idea if you need to, what to use if you need to measure temperature, volume, or mass. And towards the end, what you are going to do is calculate the density of a liquid from experimental data. And you are going, you know that density equals the mass divided by the volume. That means that if you have a graduated cylinder, and let's say you measure 5 milliliters of water, then this is the volume, and you are going to weigh what is the mass of those 5 milliliters of water, and then you do your calculations. And depending on what is the precision of the mass, which kind of balance you used, you can have, okay, 1.1 gram, depending on the balance, or 2.1 grams, or you can have another balance that will give you 2.103 grams, or you can have a balance that will tell you 2.1034 grams. So depending on if you use an analytical balance or a small balance, you will have a different amount of digits. For the analytical balance, you need to write all the digits. And for the volume, depending on what you use. If you use a graduated cylinder, you will have one kind of precision, and you will say, okay, maybe the volume is 5.0 mLs. And you can measure with a Buret, and you can say 5.02 mLs. Obviously, if you have 5 mLs if your liquid is water, you cannot have 2 grams for 5 because the density is about 1. But it doesn't matter, it's a different liquid. So this is all what you are going to learn at the end of this workshop. What kind of equipment is in the lab, the precision that gives you, and also to calculate the density with the percent error. What is the percent error? The percent error that you are going to calculate will tell you about the accuracy of the measurement. And we are going to go over that. So this is the write-up of the experiment. In the introduction, they are talking, you will read about that, but the main point here is that if you read with the appropriate number, proper number of significant figures, a measurement, which you will, because if you didn't learn it in the other workshop or in the class, you will learn it today. If you read with an appropriate number of significant figure, it will tell you the precision and accuracy of the equipment that you used. So this is key. It's not the same to use an analytical balance or to use another balance, as I showed you before. All the digits that will tell you. And same with the different glassware. So this is the introductions. I will tell you that the amount of significant figures is telling you what kind of accuracy has the equipment that you are using. So this is the main thing that we are going to learn. What else is talking in the write-up? Measuring temperature. Everybody at this point is common sense, had fever, and you use a thermometer. So you use a thermometer to measure temperature. But the thermometer, you know, they are glass tubes, right? With a little bulb here. Everybody use a thermometer. Maybe now they are digital, but let's think about the other thermometers. And are glass tubes that are filled with either mercury. We don't use mercury because it's toxic, but we use it with colored alcohol. So basically, if you put the thermometer in hot water, depending on the temperature, it will expand and it will show you here there is a scale in this tube, and you are going to read the thermometer, the temperature that is marking in the thermometer. I will assume that not everybody still understand how many digits you need to write when you read a scale. So let's go over that to make sure. If you look at this drawing, if you can zoom in your screen, if you don't see the thermometer, if you don't see this big enough, because we want to make sure that if you look at this thermometer, you know how many digits you have to add to your number. So what is, when we have a scale, what is the first thing that we need to do when we have a thermometer? We take the thermometer in our hands and we look at the thermometer. What is the first thing that we have to do? Well, we have to look at the scale. That is the key. So let's look at this here. You have the 40, number 40 here, right here, and then you have a 50, a number 50 right here. What you have to look is the two markings that are next to each other. So tell me, in the middle here is 45, right? So in the middle is 45. Now, there are also smallest markings, 1, 2, 3, 4. So I will ask you, so this is 50 Celsius. The smallest marking, the question is, two markings that are next to each other, what temperature they represent? So the question is, if this is 40, the first little line that is up to the 40, what represents? Okay, you please answer. You can message or unmute yourself. 41. Yes, Carissa. That means, but you have to look at the difference. One is 40 and the other is 41. Perfect. What is the difference? 41. So 41 minus 40. Yes, 1, Carissa, perfect, 1 Celsius. And that is the key for each instrument. I will tell you why. 1 Celsius. So what you have to do is look at the scale and say, okay, one line and next to the other. It jumps in 1. The first, if this is 40, the next line is 41. The following line is 42. It jumps by 1. So that means that when we look at this thermometer, at this red liquid, the red alcohol that is showing the temperature, tell me, what do you see? That your value X is in between which two temperatures? Yes, thank you. Awesome, Blair, Carissa, Carla, everybody. You nailed it. So what we are saying is that our value is between 44 and 45. So the first thing we did is look at what is the difference between two lines that are next to each other. Now we know that our value is in between 44 and 45. What is the way to express our temperature with the correct number of sig figs? We always add 1 digit. We always have to add 1 more digit. So that means that it's going to be the next digit. If we want to express this temperature correctly, we will guess. The last digit is a guess. We look, it's kind of in the middle, in between 45 and 44. So I would say that our temperature is 44.5. And this one, the one that I guessed, has the uncertainty, has the error. And if somebody gives you this thermometer and you want to express the temperature correctly, you have to say 44.5. But you have to do then, once you do it many times, you are going to be familiar with that. But what happens if I give you a thermometer that the lines are, let's say, 1, and this is 2 Celsius. And I will tell you that the alcohol is here, let's say. How are you going to express the temperature? You know that the value is between 1 and 2. It's the same thing as before. So you can say, okay, it's closer to the 2. You can say 1.6. But what happened if you have a thermometer that you have let's say 10 Celsius and 20 Celsius, and your temperature marks here? You know, you look at the difference between two close markings, and you know the difference is just 10. Jumps from 10 to 20, so 20 minus 10 is 10. So then what happens is that your value is in between 10 and 20. But you have to guess. So you are going to say that kind of your volume is approximated 15. But this one, the 5, has the uncertainty. And you see there are no decimals, like in the other thermometer, because instead of jumping 1 by 1, it jumps 10 by 10. Any questions? Okay, so we are going to see more examples. We are going to do more practice problems, and but stop me anytime. And then temperature reading, we saw that. And here we are measuring volume. We are going to see that this is a graduated cylinder. We use different kind of glassware to measure volumes. Let me share a page with different pieces of glassware, because here there are many things that I wanted to show you. Okay, these are different pieces of glassware, and there is one video that you need to watch, and then some questions are going to be in the quiz that you need to address. There are so many pieces of glassware. This one, the first one, is called Beaker. What happens with the beaker? Beakers are good just for like temporary containers, if we have to pour some and use it as temporary containers, but they're not good to measure volumes. See the scale? 100, 150, 125, they don't have a good scale. So these are just temporary, and this is called Erlenmeyer Flask. Is also another piece of glassware that we have in the lab that is also not good to measure volumes. But this is good for when you do titrations and when you do you mix, you do stirring mixes. So every piece of glassware has a different purpose, but not to measure these two. Then there is another kind of glassware that is called volumetric glassware. As you see here, the first one is a graduated cylinder. And it has a scale that starts from the bottom and goes up. And you basically look at where is your liquid and you read the volume. How do you read the volume? Here there are other graduated cylinders. You are going to see some in the videos. What do you need to know about the graduated cylinders? Well, first of all, what it was here. You will have, when you put a liquid, the liquid is not exactly straight. See, the liquid will do a little, this is called meniscus. So it's going to be attracted to the sides of the graduated cylinder, to this side. So when you read, you have to do two things, and they are going to ask you in the quiz. First of all, when you have the meniscus, where do you read? You read the bottom of the meniscus. So if you have the scale, and here it says 3 or 30 or whatever, you read that. And you have the scale here, but you don't care. You read the bottom of the meniscus first. And then where do you have to put your eyes? You have to go lower or up, whatever, to put your eye at the level of the meniscus. If you look from here, if your eye looks from here, you will read a lower value. And if your eyes look from down, you will read a higher number. So what you need to know is put your eyes at the level of the lowest part of the bottom of the meniscus, and then you will have a correct measurement. So this is basically what you need to know. And then here, they're showing different sizes of glassware. Basically, do you see that it has this yellow thing? This is called a grace. Yes, yes.
I just had a quick question. I was looking for, is there any other students in here? Like, is there a group message or anything where the students can see each other and talk to each other?
Okay, so you are not trying to come to the workshop 1406?
I am, but I was also looking to see if there were any other ways that we could get in contact with our classmates.
Sure, but that won't be in the workshop. After the workshop, or after the workshop, you are welcome to stay if they are here, and you can do it together, or you can leave the session and go to the main section of the, the tutoring center, not the workshop, and they will give you a room to work definitely virtually with your friends. Yes. Did I answer your question?
Yes, ma'am. Thank you.
You're welcome. Okay, so let's continue. We were talking about these yellow bumpers. If not all of the graduated cylinders have bumpers, but if you do have a bumper, you keep it up in case this fails. If this actually falls, this bumper will basically prevent it from breaking it. That's all it is. So if you see a yellow, some of the cylinders come with that yellow, you keep it up or toward the top, basically to protect in case it falls down, it won't break. So pay attention of all these little when you look at the videos, there are only 3. We'll talk about them later, but take notes, as I said in the first workshop. Take notes because sometimes the questions are like that. And you didn't pay attention because you thought it's not important. But everything is important when you work in a lab to get good habits. So let's go back to the glassware. So we know how to read a graduated cylinder. And here we see a lot of volumetric glassware. Each piece of glassware has a different precision. So you will calculate the density, measuring the volume with a graduated cylinder and measuring the volume with a Buret. And the Buret is more accurate than the graduated cylinder to measure volumes. This volumetric pipette, see it has is like a little tube, and then it has a globe, and then these kind of pipettes are only to measure a specific volume. So you cannot measure, it doesn't have a scale. Basically, this can be a 10.0 ml volumetric pipette. And it's basically, the error is given by the manufacturer, and there is another kind that is a graduated pipette that you can measure different volumes, and it has a scale. And then the Buret, that is a tube here, and here it starts from here you have a 0, and the scale increases going down. So let's say here you have 10 mLs, and this is what you are going to use to do the density the second time. Okay, for now I think with glassware we are good. Any questions about glassware? So we saw measuring temperature. And let's do some practice. Here is showing, in this graduated cylinder, is showing how you put your eye level at the bottom of the meniscus, and they tell you that the answer is, or the volume is 66.1 to 66.3. Why is that? Again, in this graduated cylinder, 2 lines, 2 markings that are next to each other represent 1 ml. So they added the uncertainty, and they are guessing. Basically, they are saying, okay, my value is here between 66 and 67. But because it's so close to the 66, they will say, okay, my value, I estimate 1 digit, and I will say 66.2 mLs. And that's why if you say 66.2, that means you have an error that your value is between 66.1 and 66.3. This is the uncertainty. Every time you do a measurement, you will have an error. Here I see a question, and it says, is the uncertain number a sig fig? Yes, you count the uncertainty as a sig fig. So if I give you this number 66.2, you know that the last digit has the error and the uncertainty. But if I ask you how many sig figs has this number, you will say it has 3 sig figs. You're welcome. So here, in the write-up of the experiment, of course, take your time to read it and to look at all the videos. If you do that and you come to this workshop, I can tell you that you are gonna get 10 each time. That happened last semester. You're going to get the maximum grade. I believe so. But take the time to take notes and write, and obviously come to the workshop if you can, or watch the videos. So here you see volumetric glassware. That means it will measure with more accuracy. This is the volumetric pipette. You see a number that it says, what does it say? It says 100, no, or it says 10. I cannot see, but you can measure only that volume because it doesn't have a scale. So the first one, A, is a graduated cylinder. It's showing you a volumetric pipette, which is this one, a graduated pipette, which is this one that has the scale, and you are going to measure with 1 digit. We are going to add 1 digit as the uncertainty, and then you have the Buret. You will probably wonder, what is a Buret? This is a Buret. It's also a tube, and you have, this is like, is a stopcock that you can open and close. So if you want to measure an amount of water, what you do is, you put the liquid here, right? You use a funnel, a little funnel, and you put the liquid here. And let's say initially, this scale goes from up down. It increases going down. So if you have a liquid right here, let's say showing you 1.2 mLs. So what you do, because when they give you the data using the Buret, you need to know, they will tell you, okay, the initial volume of the liquid, it's high, it might be 1.2 mLs. And then you open here, you open this stopcock, you put it vertical, and the liquid drains here, and you pour some, let's say, in a beaker. And then you will have, this is the initial volume, and then it drains, and then the marking is here, the final volume. And then you will have a beaker here with an amount of water. And you want to know what is the volume of that water. If the final volume is, let's say, 5.7, Can somebody tell me what is the volume in this beaker? Initially, I had the liquid here. And then I open the stopcock, I drain some of the liquid, and I close it here. The amount of liquid that is in this beaker is just this. So it will be 5.7, the final volume, minus the initial volume. So what is that? Yes, thank you. Thank you. So this is what you will have to use in the report. We'll go over later, but this is how you use a Buret. You look at the initial volume and the final volume. And you don't have to, and you don't actually, it's a mistake to try to align the volume in zero, exactly in zero, and measure only one time. The idea is to have, because every measurement has an error. So the idea is to have the same error when you read the initial volume and then the final volume, and they cancel out. So it's not a good idea to align the liquid exactly in zero, but to read the initial volume, final volume, and then calculate the difference. This is how we are going to do the report when we get there, using the Buret. And this is a volumetric flask, also has a line, and it will tell you we have 25 ml, we have bigger ones of 50 ml, of 100 ml, but it will, what you know is that if you use that piece of glassware, you are going to have a good accuracy. So we use it when we really care that what we measure is as much as accurate as possible. Any questions? So let's continue. Then comes the part where it's telling you that you are going to calculate the density of a liquid using two pieces of glassware, and the mass you will use it with this is a digital balance, but it's not that accurate. But they are going to use when you use a digital balance, you have to write all the digits. In this case, it will tell you here it's a 0.00. That means it gives you 2 decimals. There are other analytical balances that are like boxes. They have shields on the side. You measure inside, and you can open actually the sides, and they can tell you like 3, they can give you 4 decimals, 2, 3, 4, 5, and we have that analytical balances in TCC in the lab. We use that. So this one is showing just 2 decimals. Okay, so we are going to use measure an amount of water, measure the volume, and use this formula to calculate it. And then what else is telling us? We are going to calculate the percent error. And they give you the formula. What is the percent error? What tells you the error? Who can tell me? Do we need to calculate the percent error? We are going to use this. Look at the formula. The percent error, it says experimental value, which is the value that we are going to calculate. In your case, the data is going to be given to you because you cannot access the lab. But is the experimental value is what you calculated for the density. Let's say whatever you got, 0.94. The accepted value is the value that is in literature. So you can look for that value and it will be given to you, divided by the accepted value. If you look at the formula, you will have an idea of what basically, what tells you. If you have, it will tell you the accuracy of the measurement. You did an experiment. Okay, how accurate is that? How accurate is your measurement? Because you know that each measurement has an error. Okay, how accurate is that? So you do the percent error and you will know the accuracy of that measurement. And what is accuracy? Because we talk about accuracy. Okay, it's a measure of how close is your value to the calculated value. How close? Let's say they tell you, okay, the density of the water at 25 Celsius is 1 gram per millimeter. And you obtain a value that is 10.5. You have a huge percent error because it's very far from the value that is the actual value. So if you look at the formula, experimental value minus accepted value, what happens if you get your experimental value equals to the accepted value? Two numbers, let's say 3 minus 3, the same value, 0. Your percent error is going to be 0. I will say it again. If the experimental value is equal to the accepted value, because of the formula, the percent error is 0. And as the accuracy of the measurement decreases, the error is higher. If your experimental value is far away from your accepted value, then the numerator, this part, is going to be high. And then the percent error is going to be higher. So this will give you an idea of how accurate are your measurements. And you are going to calculate that at the end. So the accuracy is telling you, okay, how close is your value from the actual value. This is that's all it is actually. And then for now, let me see. Here, they will tell you how to proceed with the experiment. So before we do that, we are going to do some practice problems, and then we'll go back to this and to the report. It's 2:15, and I usually try to finish in an hour. Maybe today it will take a little longer if it's okay with you. If not, tell me if you want me to finish with the report and then the practice problems. If you can stay, I'll try to make it a report. I can say on. Okay, let's go on the report. Sure. And then the practice problem has to do with the quiz. Some problems that are explaining similar to the questions that you are going to need for the quiz. So let's go to the report first, because you will have to, well, you have to do both. But so here, basically, what you are doing, part one, you are going to calculate the density of an unknown. It happens that you're going to do water in both times, but what is the difference? Here, you are going to measure. Okay, great, Luciana. Okay, so I'll do it later. Yeah, and then that's great. We'll do everything. So we'll finish with the report and then we'll go with those problems. We are calculating the density of the unknown, right? This is all it is. It's a simple report. So you are going to calculate the density like mass divided by volume. What is the difference between these two? That the volume in part one is measured with a 10 ml of graduated cylinder. And what is the difference between the two? Part two, we use this Buret that we were looking at before. So you will have an initial volume, and then you will have, let's say they finish here, final volume, and you are going to calculate the volume that is in this beaker by final minus initial, and you use a piece of Buret. So now let's go to the report, and the first part of the report. If you do an experiment, you have to do several measurements because each measurement will have an error, and then you are going to calculate the average. So when we, let me look at what is the data, because you're not in the lab. So all this is going to be given. When you click on your report, these are numbers that are going to be in red. It's going to be given. So you will have the grams. This is part one, measurement with graduated cylinder. So they will give you all these numbers. Let's say they will say, okay, is I don't know, whatever, 13.234 grams. So you will have all this. So the mass is given. There is nothing that we need to do. And then using a Buret, also all this is given. And then all you have to do is calculate here the density. Here, this is what you have to calculate. How? Let's look at the first one using the graduated cylinder. So they will give you, so you have, what does it say? So it's very simple. We say that the density is mass divided by volume, right? So trial one, you use the mass that is given for the first part. Here, this is the mass that you are going to use. And what is the volume that you are going to use of liquid? It's going to be given. But now I'm seeing that here, look at this. They won't give you the mass directly. Look, 10 mLs of the grad cylinder plus 10 mLs of unknown liquid. So that means, okay, so the mass, stop me if I'm not clear. So what happens is that they will tell you, okay, I have to wait in a balance, but I have to wait in something. So this is empty. I waited and I have, let's say, X grams, empty. And then I put the liquid. This is 10 this is here, empty. 10 ml of the graduated cylinder, empty. And then I put the liquid. I have the liquid here. And they will give you the mass, the total mass, which is the mass of the empty plus the mass of the liquid. They are trying to make it just one calculation for you. So you have here the grams of the empty cylinder plus the liquid, and here the empty grad cylinder. So all you have to do is what? How do you know when you are going to calculate the density? Is the mass of the liquid. You don't care how much is the empty. Is the mass divided by the volume, right? What is the mass? It will be this mass minus this mass. Is it clear? Any questions? Why do you have to subtract this minus this? Any questions why? Because you have the mass of the graduated cylinder that is empty, but you care on how many grams of liquids. Does it make sense? Okay, so basically you do in trial 1, A, and this is B. So here in the density, you are in the mass is going to be A minus B. And then you divide by 10 because the volume of the liquid is obviously 10.0. Any questions so far on that calculation? It's very simple. Okay, I'll stay at the end in case something was not clear. And then what happened with the second part? Instead of measuring with a graduated cylinder, as I said before, you use a Buret, and they will give you the initial volume and the final volume. So you will have to calculate the volume. You can do another column here, the volume for all the trials, the volume of the liquid, and it's going to be, for each one, is going to be, if this is A and this is B, is going to be B minus A. So you do column B, the final volume minus the initial volume, and that is the volume, the mass is given, and the density is just as we did before, mass divided by volume. Any questions? Okay, and then we are going to calculate the percent error for the density when we did it with the graduated cylinder. So they will tell you in the report, they tell you what is the actual value. So you will use the formula, the same formula that you used before. Let's say you calculated a density. Here they will tell you what is the record temperature, right? So they will tell you the actual value. So let's say in the first one, when you use the graduated cylinder, your density was 0.994. Let's say that. And the calculated value, they give you the value, the calculated value of the density. It's in the report, is 0.997044. This is the value that you have. So when you calculate the percent error, if you got that number, 994, you will have a different number. The calculation is going to be the actual value, 0.999744 minus, I'm just using the formula, 0.994 divided by the actual value, 0.999744 times 100, and you're going to get a value there. Let's say you can get a value of around 0. I don't know, 1, or, well, this one will give you another number. But this is going to be your percent error. Then you do the same for the Buret. Now I ask you, which one you think is going to give you a smaller percent error? Which one, the Buret or the graduated cylinder? Which one measures the volume? Yes, awesome, Blair. Yes, very good, because you did the measurement of the volume with the Buret that is more accurate than measuring the volume with the graduated cylinder. And then when you calculate your percent error, you should get a smaller percent error with the Buret. And here they will ask you, what does the percent error tell you about the accuracy? And we know that a smaller percent error has a value that is closer to the accepted value. So what is going to tell you? That if it's smaller, as the accuracy of the measurement is smaller, the percent error is higher. Does it make sense? So to make it easier, if we said that before, that if the experimental value is equal to the accepted value, the percent error is 0. So if it's smaller, means that with the Buret, we have a measurement that is closer to the accepted value. Any questions there? Okay, so then the last part, we'll do a few problems that I actually prepared. I wanted to talk about the video, but let's do quickly, let's share some practice problems, and that you will probably see something similar. Okay, if you understand this, just tell me and we'll go faster. How do you determine the last digit in any measured number? Who can tell me that? What is the last digit of any measured number? The last digit is the estimated digit. And we need to estimate the last digit based on the distance between the smallest markings. This is what we mentioned before. Okay, and we know that the balance will, if it's a digital balance, the estimated digit is still the last significant figure in the measured number. I guess you know that. Okay, so let's go to the second. What is the correct way to report the length of the rectangle in centimeters? Can somebody tell me what is the answer of this? And then we'll move fast. There are not that many. Very good. Excellent. Yes, thank you. That's perfect. That is perfect. We know that our value here, let me see. Perfect. We know that our value is in between 1.6 and 1.7. Let me see what you wrote. Exactly. Very good, Carissa. Yes. And then you estimate one more. Perfect. Okay, let's go to the next one. Okay, what is the value of this one? Who can tell me? Message me here. Our value, we look at the closest marking, 15, 16, 17, 18. Our value is between 17 and 18. So what is the answer? If I tell you what is the volume in that graduated cylinder? Yes, awesome. Yes, Carissa says 17.4, and if somebody comes and says for 17.6, it's okay, because this last digit is the one that we guess and is the one that has the error. Thank you, this is good. Okay, and then what is the pair zero button on the balance? This is when you watch the videos, you will see, you will need to know when you, even though you are not in the lab, how to use a balance. So the balance, let's say, here, and you have a beaker. You want to know how many. I'm so bad drawing, but okay. Doesn't look like a balance, but you can imagine that this is a balance. So let's say I want to weight, I have a beaker with some liquid, and I want to weight on the balance. There are two ways of weighting the balance. Either I weight the empty cylinder, and then I add the liquid and then weight it again and do the difference between the beaker with the liquid minus empty beaker, or I can do something else using this zero button. It's like you basically have the balance and you put the empty beaker on top of the balance. So you have an empty beaker. And you have a scale here, and you have a button that is the zero button. When you click that, the scale is going to show you 0.000, even though you have the beaker on. You zeroed it out. And then all you do is you add the liquid, and you don't have to subtract. It will tell you exactly the grams of the liquid. And what happens if you zero once you have if you have the beaker with your liquid inside and you tear the you zero up the balance, then you don't see the weight. So you have to remember those 3 steps. First, you put the empty container, can be a beaker, can be a wherever you are going to weight. Then you zero, and then you add whatever you want to weight. You add your sample to the glassware and record your mass. Sometimes we use some little boats, plastic boats. So first you place the boat on the balance. You tear the function, like you zero, then you add your sample and take the weight. Okay, so that is important, even though you are not in the lab. You need to be familiar. And look at this question. There is one video that is talking about clamps. There are 3 videos. One is talking about the balance, watch it. The second one is talking about the glassware. We went through that. And the other one, watch it, is talking about different clamps. There are clamps, different pieces of equipment. Some clamps are to support a filter funnel. Some are to place clay triangles. So watch that. But here, what is happening is that this clamp holds the Buret, and this is called ring stand. So the question is, what do you need to do if your setup is unstable? What do you have to do? What is important basically is that this is a ring stand. This is iron, so you have a ring stand. Sometimes the base, if you have a huge equipment, let's say anything that you have here, is going to be unstable and it's going to fall. So you will have to get another ring stand that is bigger, depending on the size of the equipment. And basically, pay attention when you watch the video, but then you might need that piece of information. So, and I think for now, this is all. We are going to finish here. I will stop the recording. I want to thank everybody for being here, and I'll stay in case you have some questions. Thank you.